think more people coming, so they will tell.
Oh,
Okay, so you can start.
yeah. So I'll just start first. So hello everyone, thanks for coming to this talk. My name is Clement, and today I'll be talking about cloud security. So for this talk, we have three quick sections. First is we will be introducing what the cloud is. Second, we will be building a cloud native application called Shoppers. And third, we will run through the AWS Well-Architected Framework, and in particular the security pillar. So some prerequisites for this talk would be first, I assume that you have some understanding of system design concepts. So for example, networking, as well as the standard client-server database architecture. And second is we will be mainly covering AWS services, but please feel free to stop me if you have not heard or want to understand more about a particular service. And do note that concepts do carry across different cloud providers. About me, so I'm a second year electronic and information engineering student. I'm from Singapore, and this summer I'll be interning at Amazon Web Services, working in infrastructure and security. I passed the AWS Solutions Architect Associate certification, and prior to university, I worked in on-prem IT. So when you hear the cloud, we think of these three big cloud providers, and I was hoping to ask if you guys understand, when I ask you what is cloud computing, what do you think of cloud computing?
Using someone else's computer.
Yeah, so that's a really good and very succinct answer on what cloud computing is. So basically, when we talk about cloud computing, we talk about three main categories. The first being infrastructure as a service, or IaaS. And IaaS basically means to use virtualized compute resources on a cloud. And this offers us the highest level of flexibility because it really means that we have access to just a pure resource, a pure compute resource. And for some history, AWS released EC2, or Elastic Compute Cloud, in 2006. And EC2 is the standard IaaS service for AWS. So the second is PaaS, or Platform as a Service. And PaaS, you can think of it as a higher level of abstraction, where we don't need to manage the raw compute resources anymore. In this case, organizations no longer need to manage the hardware, they don't need to manage the OS, the cloud provider takes care of that. And that means that we can focus on deploying and managing our applications, and there's no need to factor in resource procurement, maintenance, or even patching. So one example of PaaS would be AWS's Elastic Beanstalk service. And the last would be SaaS, or software as a service. And basically this just means using raw applications, like your Gmail or Dropbox, for example. So yeah, so that's just the general introduction to what cloud computing is. And just to share a bit of background, prior to university, I worked on-prem. And it was really messy because we had to manage a lot of cabling. And there is a lot of overhead when it comes to setting up operations and performing updates, manage configurations. And although tools like Ansible or scripting makes life easier, there's still a very obvious hardware aspect to it. And the good thing about the cloud is it makes things really simple because you don't need to manage cabling or so when you troubleshoot problems, it takes away a lot of the more complicated physical issues that might come with hardware. And furthermore, for on-prem, there really is a aspect of having to manage your own high availability and disaster recovery. And what it means is when things go down, you're responsible for basically dealing with it, whereas in the cloud, it's much simpler to adjust your infrastructure to provide resiliency. So yeah. And the last thing, really important, is about scalability. So on-prem, it's really hard to scale up because when you want to scale up, you need to buy more servers, you need to hire more manpower, and you need to install those servers, and that takes a lot of time. Whereas for the cloud, it's very easy to upskill, and you just need for example, AWS, you can easily trigger and auto-scaling group, which will automatically increase the amount of compute resources based on demand. So yeah, previously I deal with cable problems. Sometimes when you plug a cable out and plug a cable in, it magically works. Yeah, you don't really experience that. So next, some statistics, just to understand the larger societal impact of cloud. It was found that for like companies that are not using on-prem and for companies that switch to cloud, they've actually lowered their costs by 51%. And also for GE, or General Electric, after the cloud migration, they found that they had a 50% reduction in the total cost of ownership. For Dow Jones, after migrating their data center to AWS, they actually saved over $100 million in infrastructure savings. The cloud also goes a bit further into hybrid cloud and multi-cloud. And what that means is for hybrid cloud, it is using both a public and private cloud. So previously, I talked about 3 big cloud providers, and this includes AWS, GCP, and Azure. And these are what we call the public cloud, where anybody can use it. But there's also this concept of the private cloud, which really delves into companies like Nutanix and Dell, which provide private cloud services. And sometimes for reasons such as security, companies might want to use a private cloud. So there are architectures that involve both public and private clouds, but we won't really go into that. And certain organizations with greater security requirements generally stick to this kind of hybrid cloud architecture. There's also multi-cloud, where companies separate their workloads into GCP, AWS, and so on. And the reason is because companies want to avoid vendor lock-in, and they want to avoid high costs, because for certain companies, they might charge a lot for one service, but other companies might charge less. So now we'll be building a cloud-native application called Shoppers. I found it on the AWS blog. And yeah, you can just think of it as an analog to Amazon. And there's 4 key aspects that we will focus on. The first is scalability. Second is resiliency. Third is observability. And fourth is security. So we start with the on-prem architecture. And in this on-prem architecture, we see a very simple client-server database architecture. You can imagine this part as being within our data center, where we have servers running virtual machines that contain programs that serve these functions. And as previously mentioned, there is a lot of overhead. We need to self-manage our security. And lastly, self-manage our high availability and disaster recovery as well. And lastly, it's very tough to scale. So if you want to scale, you need to buy new servers. So understanding this on-prem architecture, we will now start to migrate it to the cloud. And starting with a very simple cloud architecture. So can I just understand how many of you have seen cloud architecture diagrams before? Right, so this might be your first time. So I'll just give a very simple overview on how to understand this diagram. Basically, in the architecture diagram, we lay out what resources the service will use. So for example, these services are contained within the AWS cloud, and it uses, for example, a load balancer, web server, app server, and database. And these tap into various AWS services, such as the application load balancer, in this case over here, the EC2 instances over here. Yeah, so just to elaborate more. So this kind of architecture is what we would call a monolithic architecture, where everything is, all the software used in this application is in one stack. And this architecture basically contains a EC2 instance running web server, EC2 instance running app server, as well as a Postgres database in Amazon Relational Database Service. And some of the things that we can identify from this architecture is that first, for a high hypergrowth means like the application is scaling very fast, there's a lot of demand increasing, e-commerce application like Shoppers, we know that there's a very large database. In this case, database has tables over 200 gigabytes. Yeah. And there are some concerns with that because, well, first, we want to increase system throughput. And what it means is when customers retrieve data from a database, we want to minimize the amount of time taken for that so as to improve performance. And second is about resiliency. So over here, you can see in this diagram, the architecture is split in two. And why this is split in two is because when we deploy applications on the cloud, we want to ensure that there is high availability. And what that means is if one service goes down, there is a service available in another region that can basically take over so the customers don't notice a disruption. So in this case, we utilize two availability zones. What is an availability zone? Basically, it's a sub-region. So for how cloud services work is that their resources are available in many regions around the world. So for example, Southeast Asia, for example, North America, and within these regions, there will be sub-regions. You can think about that like that. And these sub-regions are called availability zones. And the idea is basically to split our resources amongst the different availability zones in order to ensure resiliency. So yeah, over here, I just want to talk about scalability. So as you can see, in this architecture, we use an auto-scaling group. And what an auto-scaling group basically does is that it automatically scales the amount of compute resources available based on demand. How this works is it tracks metrics such as CPU utilization, and from these metrics, it decides how to scale your application. But there is something to take note. Scalability doesn't happen instantly. New services might require a few minutes to start, for example. So if customers grow, like the demand increases exponentially, there will be some lag time. And there are things that we can do to account for this. Moving on, we will be focusing on trying to maximize our throughput. So shift your attention from the rest of the architecture to the database. And as you can see, there are a few key differences. First, we have a proxy or app server. And second, we tap into a proxy for our database as well. We also use a cache, and we also shard our database. So let me just explain what that means. So first, we implement a proxy for our relational database service, as you can see over here. And what it means is by having a proxy, you're able to do something called connection pooling. So previously, in our previous architecture, connections to the database are not shared. So different users, when they access the database, they have their own separate connections. But by implementing a proxy, what we can do is that we can pull the connections together, and what this does is that it helps to increase throughput and reduce resource utilization on the database. Second, we also implement this thing called read replicas over here. And what it means is when we implement read replicas, we basically separate out the database access based on whether the user is reading or writing to the database. And this offloads some of the compute load on the database, helps improve the throughput. We also implement caching, where we use Redis over here to help to reduce latency by implementing a cache layer. And lastly, we do sharding. So what sharding means is we are able to split the database up. And what this does, it helps us to horizontally scale the database with several writer nodes in this case. So next, we take our architecture even further. After that, what we do is we want to focus on implementing resiliency and observability. And what that means is we want to split our region up into region A and region B. And what this does is that if something goes wrong in region A, we're able to tap into region B to continually serve our customers. And how we can do this is through a service called backup, where we copy over the different data within region A into region B. And we also duplicate the infrastructure on region B using infrastructure as code, which I will share more later on what that is. We also have, logging and monitoring. So using a service called CloudWatch, what we can do is that we can log different metrics and understand the load that our infrastructure is experiencing, and basically from there, like, do certain actions to prevent it from being overloaded. So we'll come back to shoppers. Very multi-step journey in building a cloud-native application. And just to summarize, what cloud-native means is to have an architecture that's resilient, an architecture that's observable, an architecture that is scalable, and one that's secure. But moving on, we'll be sharing more about the AWS Well-Architected Framework. And this framework helps us to understand trade-offs between different decisions that we make by building on AWS. And I think it's very analogous to the rest of system design, is that whenever we make a decision, there is a particular trade-off, and from our set of requirements, we decide the best possible decision. So the framework helps us understand that more. And there are 6 pillars in the framework, and today we're focusing on security. So yeah. So this is a breakdown of the security pillar. There are many different aspects, and today, in the view of time, we'll just share about 3, which is foundations, detection, and infrastructure protection. And I know the previous part just now wasn't really about security, but this part is like really security, like heavy. So yeah. So first about foundations, and to share about foundations, I will be sharing an example. So you may have read about like data breaches, on the news. It's really common, a lot more common now because companies are trying to digitalize. And one very common like data breach is through S3 buckets. And when we think about data breaches, I want you to think about the responsibility aspect. Who is responsible? Is it AWS or is it the company? The company does the configuration. AWS takes care of the servers. But in this case, who is responsible when a data breach happens? So in this example, we found that a Nigerian airline, Air, may have leaked customer data. And why this happened is because there was a leaky S3 bucket. So let me just show what that means. So just to like read further into the article, we see that when doing regular scanning, a security company found that there was an open S3 bucket that had a large number of CSV files. So these CSV files contain customer data, and by open, it means that public people like you and me on the internet can access the resources within the S3 bucket. So this happens because of misconfigurations. And what that means is when you set up an S3 bucket is basically a data store for like static files, for CSV files, images, and so on. We are able to set the security settings to be private or public. And sometimes companies may want to set things to public. For example, when they deploy, you are able to deploy static sites on S3. In order to have people from the internet see your static site, the bucket would need to be public. But in this case, misconfiguration can also happen. And in this case, there was a misconfiguration allowing people on the internet to see contents and to exfiltrate from the S3 bucket its contents. So, for example, over here, just to see more, this is the access control list of an S3 bucket. And when we create a bucket, we are able to configure the access control list. So what happened was the misconfiguration was basically not changed until actually a month after the security analyst like released it into the news. And Air actually denied like having this misconfiguration. So it's more common than you think. And to go even deeper into how you and me are able to find open and vulnerable S3 buckets online, how many of you have heard of Burp Suite? Yeah. So Burp Suite is basically a very commonly used cybersecurity tool to automate penetration testing. And in this case, we are able to use Burp Suite to basically implement a plugin, AWS Extender, and we can do a brute force search with certain bucket names to identify open buckets. And Burpsuite would just give us what buckets are available, and then you can do whatever you want after that, which might mean exfiltrating data inside. So yeah, back to responsibility. So the point I really want to drive home is that AWS has a shared responsibility model. And what it means is both the customer and AWS has a responsibility for security of your infrastructure. In this case, AWS is responsible for security of the cloud. And what it means is protecting the infrastructure that your code runs on. Customers are, on the other hand, responsible for security in the cloud. And what that means is configurations, patching, and managing networking. So there is a very different aspect of security, but both AWS and us are responsible for the security of our infrastructure. As developers, I think it's important to understand these underlying aspects of security so that we can avoid potential misconfigurations, like what I've mentioned just now. So next, just more administrative aspects, because cybersecurity isn't just about the technical side, it's also about the administrative side. And one aspect is really about admin access. So what we want to do is we really want to enforce a separation of responsibilities principle. So how AWS works is there are this thing called accounts. So when users go on AWS, they're able to create an account. From the account, they are able to do whatever. And what we want is as an organization, we don't want everybody to use the same account, because this prevents us from being able to set quotas and guardrails to prevent this account from overusing resources, for example, or like having potential misconfigurations. So what we want us to do is to separate our accounts out, and there are tools in the AWS console that help us to do that. So for example, over here in this diagram, we see that we have an account for networking, an account for testing, an account for development, and an account for security. So separation of responsibilities. So next, detection. Something more exciting. So detection really is about identifying potential misconfigurations in our infrastructure, like public S3 buckets, and we don't want it to be public. So there are a lot of tools to help this, and one example would be Snyk, where Snyk is able to scan our infrastructure for misconfiguration. So there's this important concept called infrastructure as code that I alluded to earlier. And what that means is instead of deploying resources in the cloud console, like on your browser, all we want to do is we want to implement it in code. So for example, we would have a YAML file where we would be able to put what resources we want to use and what are the configurations that are associated with those resources. And why this is important is because of code review for other developers to understand what you're doing and to prevent misconfigurations before resources are deployed. So yeah, we're able to do detection this way before we deploy our resources. And the next is about intelligent threat detection and understanding when malicious activity is happening on our infrastructure. And all cloud providers, including AWS, have a suite of intelligent detectors to identify suspicious activity. So one example would be GuardDuty. So GuardDuty is a service in AWS that is able to monitor different aspects of our infrastructure. So for example, on one very common suspicious activity would be port scans, trying to identify what open ports are on our service. So on AWS end, what they do is that they consolidate all the latest threat actor tactics, techniques, and procedures, and also indicators of compromise. And from there, they are able to have a database, and then they are able to perform monitoring using GuardDuty on our infrastructure, and then identify and flag out these malicious activities. For Macy, so over here, Amazon Macy is another service that basically scans our S3 buckets for sensitive data. So when we think of scanning for sensitive data, why that's important is because we don't want to put sensitive data where it's not supposed to be put. And this can include potentially identifiable information, personally identifiable information, So basically, like data tells like your personal data. Also like healthcare data, for example, which have more stringent security requirements, and we don't want them to be put in the wrong S3 bucket. And what Macy can do is that it can scan like your S3 buckets for the sensitive data and alerts you when you've done so. And how it does this is basically through machine learning. So it has to look into your S3 bucket, and you're able to toggle like whether it can scan your S3 bucket or not. So it doesn't just like go in willy-nilly. And like this basically helps you to like maintain some privacy of your data. But it has to go in, and then from there it will scan the bucket, and from the data as well as the metadata from the bucket is able to tell like the level of sensitivity within the S3 bucket. So yeah, so these are two services that perform intelligent threat detection on AWS. So moving on. Whoops. Yeah, moving on. Oops. We were talking about infrastructure protection, and this can include two forms. It can include network protection as well as concrete protection. So like this would be like hardening, but today we'll be focusing more on network protection because yeah, I think it's more pertinent, and it gives us a bigger picture understanding of how to be a good and secure cloud developer. So there are really a few aspects to this. And the first is to create multiple network layers. Second is to control traffic at the different layers. And lastly is to implement inspection and protection. So yeah, using these methodologies help us to ensure successful and ongoing operations in the cloud. So the first thing, and the first very important aspect of networking in AWS is understanding what a virtual private cloud is. So as the name implies, basically all it means is to have your own private cloud, but within the setting of a public cloud provider. So it's as if this entire cloud, like the infrastructure that you use, is all like your own like infrastructure. So it's private. So basically you have your own network inside, and yeah. But with this network, you're also able to tap into AWS services, enabling you to scale up your application really easily. Just to see it in a picture sense, as you can see over here, we contain all our resources within a virtual private cloud. So these can include like your EC2 instances, for example. Yeah.
So would AWS not have access to whatever is inside that private cloud?
So you can think of it this way. So let's say I am a user and you're another user, right? So we want to have our own apps. So for example, I have my startup and you have your startup. So our startups will not be located in the same cloud, in the sense both will have their own private cloud. So they wouldn't be able to talk to each other. But both of us have access to AWS services and our own like internal network for our infrastructure. So yeah, that is what it is. Any other questions? If not, yeah, so this is a diagram for the VPC. And now we're talking about this concept of creating network layers. And what we want to do is we want to implement a defense in-depth strategy where we basically want to have different layers that attackers have to go through like each layer before they're able to compromise our whole system. So over here, we note that a more sensitive aspect of this infrastructure would be the database. We don't want attackers to reach our database easily. So what we can do is to set, do you guys understand the concept of subnet? Yeah. So what we want to do is we want to put our database in a private subnet. And what it means is in a private subnet, people from the internet are not able to access that subnet directly. Instead, they would have to, usually when people want to like go to your web application, so for example, when you go to Amazon.com, you would open the browser, you would key in Amazon.com, and what happens is that it would bring you to a web server where it will then, for example, forward you to the different servers that will display the relevant information. So over here, we put our database in a private subnet and our load balancer in a public subnet. And then this load balancer will then route us to different places. preventing like access from people in the public from accessing our database directly. So this basically implements a defense in depth strategy. So yeah. So there are a lot of common anti-patterns that I know. So I've been using AWS for a while, and one very common anti-pattern is to basically not use private subnets. So what it means is when we create resources, we automatically deploy them in public subnets where they're able to be reached out by people from the internet. So you have to be quite deliberate about this to set up a private and public subnet in your VPC where you're deploying resources in the cloud. Yeah. So one question you might have is, what if my VPC wants to talk to your VPC? Or what if my VPC wants to talk to just another VPC? So there's this service called Private Link, which is able to connect two different VPCs together, like allowing them to just share resources securely without going through the public internet. So you might think, for example, my startup wants to send data to your startup, but what if we don't want to go through the public internet? So what we can do is set up a private link where it runs through the entire AWS global network backbone, so it doesn't touch the public internet, securing our data. Yeah. So this helps to air gap our VPCs, basically. So next, I'll be sharing more about this service called the Web Access Firewall. So how many of you have heard what a firewall is? I presume everybody's heard what a firewall is. Yeah. So firewalls basically do a very simple thing. They inspect traffic that's coming in, and based on the traffic and data about the traffic, it's able to decide whether to reject or allow access to the rest of our network. So that's the same as what a web application firewall does. At the application layer of the OSI model, have you guys heard of what an OSI model is? Yeah,
Sorry.
OSI model. Basically, the 7 layers. The web application firewall sits at the top at the application layer. So if you understand what the application layer does, it involves protocols such as HTTP. When people open a website, they send HTTP requests. So what this WAF does is that it is able to filter the different requests that are happening on the application layer and decide whether to allow access or reject based on the characteristics of the request. So what we can do, for example, using WAF, is that we are able to implement stuff like regex to basically reject certain characteristics. So for example, if we suspect that the attacker is trying to do an SQL injection, and SQL injection is basically where they send an SQL request on our website, trying to gain access to our database, we're able to use WAF to block that. Yeah. So yeah, other things you can do include blocking country of origin, an IP address, and just preventing people that you don't want access to your website from accessing it. So yeah, as you can see in this diagram, data comes in by Route 3, and then it goes to the WAF, and WAF decides whether to allow passage or not to further resources, like for example your load balancer. So yeah, so this attacker sends in SQL injection, but we detect it on our WAF, so it doesn't go through. So yeah, this is one more example of a defense in depth strategy in the cloud. So next, moving on. So that was the web application firewall. So now we're going to go further down into the OSI model, from the application layer to the network layer. So there are 2 kinds of firewalls in AWS, and it's a bit confusing. When I was studying for my test, I wasn't too sure what the difference was. But basically it's very simple. Both just sit at different layers of the OSI model, and they filter for different things. So the network firewall basically is a more fine-grained way to control our network traffic. It can sit within our VPCs, and then from there decide whether to allow passage from, for example, one subnet to another subnet. So it complements existing security services, and it provides greater visibility and control over the lower layers of the OSI model. Yeah. Moving on. One more thing that we can do is logging and monitoring. So logging and monitoring is a really important aspect of not just security, but also like after we deploy applications on the cloud, we really want to monitor and like basically understand the logs to see what went wrong or what could go wrong. And for security, it's really pertinent because we want to understand the logs of, like, for example, who has accessed our VPC from the internet. And from there, we are able to parse together information to tell how attackers might attack our infrastructure. And in fact, the VPC logs are one way that GuardDuty does intelligent threat monitoring for infrastructure. So next, we return back to shoppers and see how we can implement a security layer to our cloud-native application. So as I mentioned earlier, we want to implement a multi-account strategy. We don't want one account to control all resources. And we want to use different accounts in different organizational units. So for example, over here, security, infrastructure, and workload. And we want to set guardrails to prevent like these accounts from doing, going over the quotas or like having access to resources that they shouldn't have access to. So what you can do in AWS is you're able to control whether a certain account has access to a certain resource. So for example, if you aren't touching, like if you aren't supposed to use like S3 buckets, you shouldn't have access to S3 buckets. But yeah, this can be configured. So we want to set guardrails like that to prevent potential misconfigurations from happening. So yeah, other things that we can do is multi-factor authentication. And how this works is we are able to implement a token using security token service over here. And this helps us to generate temporary credentials to secure our account. On a more personal side note, I use MFA as well for my own AWS account using Google Authenticator. So this means that although you might have access to my password, you need my phone to access my account. So yeah, MFA is really important. The next is to use the different security services that are available in the cloud to help create a workflow to do stuff like threat detection and incident response. So threat detection and incident response is also really important because we want to know when threats are happening and we want to respond to them. So this is an example of a workflow that we could implement. So think about it, like think about yourself as an analyst doing analysis of different data points to perform a comprehensive IR strategy for shoppers. So briefly used over here in the diagram. We can tap into different services, like for example, GuardDuty, Macy, and Amazon Inspector. And what we can do is that from these different data points, we are able to integrate them together using a service called Security Hub, which can then intelligently create Jira tickets. So have you guys heard of Jira? Yeah, so Jira is basically a project management tool for organizations. So we can create tickets that our team, like you and me, can go and deal with. For example, to go and inspect a certain resource for potential intrusions or misconfigurations. So yeah, basically I elaborated earlier about GuardDuty. I talked about Macy, and over here we have Amazon Inspector. So Inspector basically runs vulnerability scans on our compute resources, like our EC2 instances and our Docker containers, to find potential vulnerabilities. So that's what Inspector does. And yeah, it checks for vulnerable software. So if you guys done like pen testing before, one very common way to find exploits is through vulnerable software, outdated versions. And Inspector basically helps us check our resources for that. So yeah, we can then integrate all these findings into Security Hub and then do some prioritization intelligently to take out the most important threats first. So yeah, so that's really the end of everything I have to say. The next part is about further reading if you want to learn more. First is a very popular podcast by Google Cloud on how they do cloud security. Second is through white papers by AWS. And third is a book called Hands-on AWS Pen Testing with Kelly Linux. So This is a very good book to understand how to pen test your AWS services. Over here, there's this tool called Paku. So Paku is a tool that's specifically designed to pen test AWS services. So you can just go and read more on how you can use Paku. So yeah, and yeah, these are my references. So if not, that's all I have to say. Thanks so much for coming. And yeah, that's the end. Do you guys have any questions? Thank you. Yeah. Cool.
That was good.
That's all.
I like that.